All right, so one more time, this is 3B, and we're going from, we're trying to calculate the mass in grams, and so we started out with 2.5 moles of sulfur, and we're trying to go from moles to grams, and we are allowed to do that in one step. Now, I do need another favor. Brett, since you're playing on your phone, do me a favor. Will you pass out the periodic tables? Thank you, sir. So my first question is, if you see moles, what does moles always get? Moles always gets a 1, and if you see the letter G, where does that value come from? Periodic table. Does anyone happen to have memorized sulfur? Look at you. Somebody did have it memorized. Look at you. Again, and I told you guys this the first day because I always get asked this question the first day of class. Do I have to memorize this thing? No. But you have eventually memorized it. We're, 8 months into this year, and you know where pretty much everything is without having to memorize it. Does it help? Yeah. But now, this is where you actually have to take your calculator out and you actually have to calculate this, but it's a very simple question. Now, I did write this down correct, and remember there's always 3 things you have to have in your answer. One of the things is the correct number of significant figures, and I hope you remember this. How many significant figures are in that number? There are 2 numbers. How can there be 1? It is 2. Now, somebody help me out and tell me the exact answer you get in your calculator when you multiply these. I want the whole value. Oh, I missed the 80. 80.15. So, here's the deal. You then have to recognize, okay, I need 2 significant figures. My calculator popped up 4 of them. So what is your answer to 2 significant figures? 80. 80. Now, this is where some of you are going to get gotten. Okay, I'm going to get you here. If you leave it as I currently have it, is that right or wrong? That is wrong. How do you make it the second? Very good. That decimal point makes it 2 significant figures. Okay? If you don't remember those rules, you need to go back and learn them. I'm not helping you out on that. Finally, the last thing, we've got to have a unit, and we've got to have the compound of the element. So it's 80, exactly 80 grams of sulfur. Exactly 80 grams of sulfur. Okay? All right. Now, let's do one that's a little more challenging. Yes, ma'am. She's on her way. Thank you. Bella, don't forget about Monday, okay? Alright, so this time, I want to convert from 1.3 moles of gold 3, what's that polyatomic in parentheses? Chromate. Gold 3 chromate, and I want to try to determine how many grams that's going to be. Now, we always set it up as normal. If moles is on top and I don't want it, where do I put it to cancel it? Put it on bottom, and I got to go to mole to grams. Now, this is why this question is a little more challenging. First of all, I know I got a 1 by moles. Is there one single box on the periodic table with that thing in it? No. So this is where you actually have to know how to calculate the molar mass part of this. So let's practice doing that one more time. So you're actually going to see me do it. You set it up as we've always done before. AU, CR, and O. How many golds are there? There are 2 golds. How many chromiums? There are 3. Now where in the world did you get that 3 from? You got to distribute that 3 to here. And then how many oxygens are there? There are 12 of them. Very good. So that 12 is because that 3 is distributed throughout those parentheses. Now you got to look up on the periodic table. I will need your help on this because gold is like 196 point something, right? 0.97. Okay. Chromium is 52 even. And then oxygen is 16 even. Okay. Now, here's my ultimate goal for you guys. Once we do this, I'm going to go and show you a faster, more efficient method than having to do this for every single problem. There's a way, and I want you to get to the point where you can actually do every bit of that in your calculator. You never have to write it down. Okay? And I'm gonna get you to try that out in just a minute. But first of all, let's do it as we've always done it. What is 2 times 196.97? It's like 3 something. 393.94. 52 times 3. 156 even, and then 12 times 16. Oh, what'd you say? 192. Dadgum. Alright, so we got to add all this up. So we've got 0.94. I've got 9. I've got 11. 18. 19. 24. 2. Yep, so 741.94 grams per mole. Now, let me show you how I would have done this without writing any bit of it down. So what I'm going to do is I'm going to pull up my fancy calculator. Pull this back up. This is how I would have done this. If you guys will learn how to use your parentheses, all of this hard, difficult writing down math goes away. So I'm going to open a parentheses, and I'm going to do 2 times 196.97. I'm going to close my parentheses, and then I'm going to start another set of parentheses, 3 times 52, close it, and add one more set of parentheses, and that time it's 12 times 16, close it, hit enter, and there's my answer. Is that again? Now, on the formula mass problems, yes, but once we start doing molar conversions, there's no reason to have to write all of this down, because do you agree that slows you down? So if you can learn how to do this, your math will speed up drastically. Okay? So I do want you to try to learn how to do it all in your calculator. Now I agree, these graphing calculators make it much more efficient, much faster, because you can see what's wrong, and if you make an error, you can go back in with these clickers and fix it. But some of those calculators still allow you to do the same thing. Now, once I plug that number into my parentheses, what do I do with the 1.30? Multiply. So times 1.30, and that's the answer that pops up. Now, do you write that entire thing down? Now, this is a really good question. I need how many significant figures from my given? 3. Remember how we did it? We've got the Pacific Ocean over here. Come on now. Pacific Ocean, Atlantic Ocean. Is the decimal point present or absent? It's present. Start with the first real number and count all of them. So that tells me I've got 3. So I'm going to pull this back up. I need 3 significant figures. So what would the correct answer be? 965. Why did I round to 5? The next number back there is 965, and it would be grams of gold 3 chromate. On that one, no, you would not, because 9, 6, and 5 are all real numbers, and that's 3 significant figures. The reason we had to add the decimal the last time is because the 0 does not count as significant unless you put the decimal in it. Okay. All right, let's do. No, ma'am, you do. You can, but you don't have to in this one. Now, if it is just a straight molar conversion question, you do not have to do the molar mass. But if the question says calculate the molar mass, you have to calculate it by showing your work. But if it just says convert this to this, I don't have to see all this. I just want to, if your mass is right, your mass is right. If it's wrong, it's wrong. Okay? Now, I want to do one more in this little part because I think it's important that we see it. What if, and this is number 3F. Number 3F. So 1 atom of carbon. I want to know how much 1 atom of carbon weighs. Is it going to be a lot or a little? A whole little, okay? So, here's the problem with this question. If I want to get rid of atoms, where do I put it? On the bottom. But look up there at the tippy top of this sheet. Are grams and atoms touching? No. Who's in the middle of it? Moles. So we've got to go to moles first. Now, Can I put my equal sign and stop? Can I put my equal sign and stop? No, because the question specifically asks calculate what? The question specifically asked me to calculate what? Grams. Okay? Now, so atoms have canceled. I'm left with moles, but I don't want it. Where do I put it? On the bottom again. And this time, I know that I can jump into the grams. Same question as we always start with. If you see a mole, what do you give it? A 1. If you see atoms, and again, it's up there at the very top of this page, what do you put for atoms? 6.02 times 10 to the 23rd. And the easy one, grams, is 12.01. That's coming right off the periodic table. I didn't have to do any math on that one. I want you guys to practice this one because I want to make sure that you can do Avogadro's number in your calculator and still come up with a correct answer. Okay. Now, in your calculator, what is really the only two numbers you have to plug in? The 12 and the 6.02. Okay. You don't have to worry about the ones. They're all going to go away. Now, are you going to multiply those numbers or divide? Divide. What's on top? 12.01. Okay. Remember, and you may not can see it, but depending on the calculator you have, right above the number 7, there should be that EE sitting right there. Try it again. Because what this E stands for, this E right here, let me change the color so you can actually see that. This E is equivalent to times 10. So it takes the place of the X and the number 10. So the calculator just won't show that. Now, if you have a Casio, good luck. I hate those things. All right, do 12.01 divided by 6.02. The button above the number 7. No, because the button is the EE button. All right, did everyone get 1.995 something times 10 to the negative 23rd? All right, Jamila, y'all back up here. Here's the part where some of you are going to mess this up. You will not catch that part. All you're going to want to write, by the way, what was my first number? What was the given? Just 1. Now, what is all of that rounded to one significant figure? 2. Some of you will literally write the answer of 2. How can one atom, guys, Brian, y'all listen. How can one atom of carbon weigh 2 grams? That doesn't exist, okay? So you cannot forget the times 10 to the negative 23rd on that answer. All right. I want you guys to practice one more on your own and see what you come up with, just to make sure we're all on the same page. I want you guys to do 3C. 3C. 0.75 moles of Al2O3, and we're trying to get to grams of Al2O3. See if you can do that one all by yourself. Again, the more you do this, the better off you'll get. All right, so let's look at this real quick, guys. Now, the first thing we need to do, Jamila and Ryan, y'all are killing me. No. Now, this is how you should have set it up. I know that I have one of those, and then I need a number here. This is a genuine curiosity question. Did anybody calculate the mass without writing it down? You just plugged it in the calculator? Did it make it a lot faster, a lot easier? Okay. And again, I just want to show you one more time. So I'm going to clear. I know that aluminum. Well, I'm going to cut it on first. Clear. I need 2 times. What's aluminum's mass? Somebody help me out. 0.98, close, plus 16 times 3, close, equals, and there's my mass. Okay. Again, it's a lot faster if you'll learn how to do the parentheses. And then I'm going to multiply it times 3/4, which gives me 76.47. But I need 2 sig figs. 76. Okay. Now, why don't you say, well, the 7 makes that 4 a 5, so that makes that 6 a 7? You don't. Very good. You don't double round. Just look at the very next number. So it should be 76 grams of aluminum oxide. Okay. 2 more, and we're done. 2 more, and we're done. So if you guys will look at number 4A. 4A. We're trying to go from 25.0 grams of H2, but look at the top. It says determine the number of particles. And it says molecules for compounds and atoms for elements. Now this is a tricky question. Is H2 an atom or a molecule? A molecule. An atom is one single thing by itself. Well, there are 2 H's, so it's not one single thing. Okay? So I'm going to set this thing. Actually, I need to do this. So let me go back and ask you this. Look up there at the very top. Are grams and molecules touching? Who's in between them? Moles. Okay, so I got to go from grams to moles. Why can I not stop there? I'm not done. I got to go one more step. I got to get my moles canceled so I can get to my molecules. Okay. What number goes beside mole? A 1. Tricky question. What's the mass of H2? Very good. 2.02. Please don't mess that up. This is just like you would do it if it were a big, huge compound. You've got 2 H's. One is 1.01. Well, there's 2 of them, so 2.02. And then finally, molecules is that big, huge, long, ugly number, Avogadro's number. Now, I want you to practice calculating this before I give you the answer. I want to make sure that you can do this in your calculator. This is a little bit more challenging than the ones we've done in terms of pure calculator issues. Alright, so if you'll look up here, I did it all in one calculator stroke because I used parentheses, and then that is my answer. Did you get that answer? Oh, I can assure you he didn't. Now, how many sig figs? 3, so it should be 7.45. And this is what scares me. Someone in this room on Monday is going to leave off the tail end of that because you're not going to pay attention to the end of the calculator. Please don't leave off the times 10 to the 24th power. That is wrong. If I were going to hand you a check for $7.45 or 7.45 times 10 to the 24th, which one do you want? You definitely want 10 to 24. So don't short me with your answers. Think about it in terms of money. Don't leave it short. You could spend billions of dollars every second and never run out of money with that other check. You can spend $7.45 in the lunchroom. 7.45 times 10 to the 24th power. Now, and that would be molecules of H2. Right, one more, and we're done. And as I said, we're going to do 2. I want you guys to do one more. Yep, actually, this is a good one. Because if you can do this one in your calculator, 675 grams of Ni2Cr2O73. Now, hold on. Just write it down. This is nickel 3 dichromate. And we're trying to get from grams to molecules. Don't start any of the calculations yet. Please, please, please. Please wait on me. So, I know that I want grams to moles, and then I want moles to cules. Here's what I want you guys to try. I want you to try to calculate the mass of that thing without writing a single thing down. Just give it a shot. Okay? Try to calculate it without writing it down. It is going to be very heavy. It's not. Massimo, it's only 3 calculations. It's 3 sets of things. No, there's not a lot of button pressing. The number is just going to be really big. There's a parenthesis right above the number 8. Right above the little 0, there's a parenthesis thing. Alright, so I've got 21 oxygens times 16. Alright, so one more time. I had 2 nickels at 58.7 apiece. I had 6 chromiums at 52 apiece. And I had 21 oxygens at 16 apiece. And so that should give me the final answer of 765.4. Okay. Again, hopefully you're seeing that it does make it much more efficient to do it this way. Okay. Well, I can do that too. All right. So I know that I need to do 675 times Avogadro's number. I mean, I've already got everything set up in my head of how it all works out. And then I'm going to divide it by that. And then I'm going to divide it by the mass, which is 765.4. And so your final answer is that thing. Again, do you want $5.31 or 5.3 times 10 to the 23rd dollars? You want that bigger number, right? Don't cheat me on that scientific notation part. Go ahead, Gage. I didn't. Oh, that's the final correct answer if you use the parentheses. I just didn't write any of those numbers down. But that's what you do because molecules is on top. And so you multiply it times 675. And the mass would be on the bottom. So I divided it by the mass. Positive 23. Because we divided by that really big number. This time we multiplied by that really big number. If you divide it, normally we'll turn it negative, yes. Yeah, it should show up as a negative number. Say that again? Yes, ma'am. 5.31. Any other questions? That's a good question. What the question was asking for molecules, so it would be no, just molecules. Because if you look at it, the grams cancel, moles cancel, so all you're left with is molecules. So it's molecules of nickel 3 dichromate. And I agree, that's a pretty big formula. Okay. All right, we are done, guys.